Welcome to the Chapter 5, Section 1 podcast. And this podcast is, this section is called How Populations Grow. And this one's, I kind of like this chapter a lot because there's a lot of numbers in it. For some reason, I just like that. So, anyways, what characteristics are used to describe a population? And the three important characteristics are the geographic distribution, the density, growth rate, and growth rate. Let's look at each of these individually. First, we're going to look at is geographic distribution, which is the area that is inhabited by a population. If you look at this, we're going to look at now population density, and that's the number of individuals per unit area. And you can see this saguaro cactus. It has a very low density. There's only one within the view of this picture. But you look at these smaller pictures here, maybe it's sagebrush, I don't know. But you can see there's a lot of them. So that would be high density within a given area. There's a lot of these, but within the given area, there's very few cacti. And lastly, growth rate is the increase or decrease of the number of individuals in a population over time. So let's look at the density here of New York State. And I thought this was a great map. We're going to look at human populations a little more in Section 3. But if you look right here, this is the area we live. And you can see this is a very densely populated area. Anything with a red is more than 5,000 people per square mile. And population of Nassau County and Suffolk County and the city, obviously, number in the millions. So you can see there's a lot of people per square mile here. It's kind of crowded here. As you go upstate, this is the Adirondacks here, and you're not going to find many people up there. And you can see there's cities right along this path. That happens to be where the New York Thruway is, and also I think there were a lot of canals that ran that way too. And here's Albany and Schenectady. This, I believe, is Utica. Here's Syracuse. This is Rochester. That's Buffalo. Down here, I think, is Binghamton and Oneonta. And you can see I have a map right here, and you can see the cities up here on the map also correspond up to here. So that's density, people per unit area. What factors affect population size? Well, there are three that affect it. Number of births, number of deaths, and people that enter or leave a population. And if you look here, I have a graph here that shows death rate and birth rate, and shows population growth. And this is showing the rate of growth, and over time, all populations, human populations, sort of follow this pattern. And maybe we'll look a little bit more of that in Section 3. So population can grow when, basically, the bottom line is when the birth rate is greater than its death rate. And if you have people dying at the same rate as people are being born, you're going to have zero growth. The other factor that comes into it is individuals coming and going. The first one is immigration, and that's movement of the individuals into an area. And often they'll come in to in search of a resource, such as mates or food, and they'll come into that area. Youngsters that are born in, say, birds will immigrate to another area looking for their own territory to establish themselves for food and for mates. Emigration is the movement out of an area, and this will cause a decrease in the size of the population. And often it'll happen when they leave to find mates or establish new territory. So if they're moving into an area to establish their territory, that's immigration. If they're moving out of an area to find new territory and new resources, that's emigration. This penguin right here, I think, is looking for sunshine, so he's heading to California. Another big one, obviously, another resource would be shortage of food would lead to people leading to one emigrating, or if there's an area where food becomes abundant, then individuals might immigrate into that area. So when we can measure this growth, and there are two types that we're going to look at: exponential and logistic. And under exponential growth, essentially, a population will just grow and grow and grow, and it will grow exponentially. And you're going to see a graph here that explains this. If you have unlimited resources, basically ideal conditions, they'll just grow and grow and grow. There's nothing to stop them from keep on growing. Now, to grow at this, you have to have a constant rate of reproduction. And like we said, the population becomes larger and larger until it would become an infinitely large size. Now, this doesn't always happen in life. Here's two examples right here that we saw in your book. This is a bacteria. This is an elephant, and you can see that the gestation period for bacteria is roughly 20 minutes, I believe, whereas for an elephant, it's somewhere in the order of, I guess, a generation of elephants is 1, 2, 3, 4, maybe 50 years. And you can see as time goes on, the population will grow and grow and grow and grow. And then it's just going to keep on heading straight up, which is an infinite growth rate. But reality, this doesn't always happen for very long. There's usually a problem with resources that will stop them. So as your resources become less available, the population is going to slow or stop. And here's a very classic S curve. If the infinite growth, let's go back to that, is what we call a J curve, then logistic growth is what we call an S curve. And it occurs when you have growth that's slowing or stopping following a period of exponential growth. So here's our area of exponential growth, and then when it reaches the point where the resources become less available, then we get a stoppage of growth. So as you can see, this is an S-shaped curve. There's our S. And what causes this to occur is when you have a shortage of resources at that point, and the number that can fit a particular environment of individuals is what's called the carrying capacity. That's the number of organisms. And here you can see on this chart we have a carrying capacity is represented by this dashed line. You can see the population will reproduce exponentially until it reaches the point where the environment can't support it anymore, and then we reach zero growth, and that's called the carrying capacity. So when we reach carrying capacity, growth levels off, and the average growth rate is 0. That means as many individuals die as are born. So let's head on to the quiz.